learned about how to design the database. Then after we design, like we have the relational schema diagram. So using this relational schema diagram, and also with the help of DBMS, like the MySQL we are using currently, or any other database management system, like the SQL Server, Oracle Server, Sybase, it's fine. Using this software, we can create the database. After you create the database, we are able to access the data, like using the Python, or the Java, or something PHP. So you can do any application program. In case we need to access the database, you can access the data and manipulate whatever you want. This is mostly the database design and the database course. Plus, from now on, from the last class, we are going to do the additionally, that is what's going on inside this DBMS, the algorithm of the database system. Like I mentioned about a lot of time, the query optimizer, how the database management system speed up to access the data. So probably I mentioned several times the main reason why we are using the database. What do you think? What is the main reason to use the DBMS? If we do not use the DBMS, it's much simpler. We don't have to worry about the database design. We don't have to worry about how to connect the database. We don't have to worry about this. Even you don't have to take this course. Right? Then why we need to use the database? And it is true, if you join any project or any real life project after graduation, your project may include the database server, database system, or depending on the project type, it can be various, but most of them use the database system. Then why do we need the database? We have first very large database. Then what's the problem when we have a very large database? So speed is the problem to access the data. If we can solve any such a problem with our program language, we don't have to worry about this. But the program language itself cannot address such a speed issue to access the data because it has many. So this is my personal opinion. If somebody asks what is the most important part of your database when you select the database, so somebody said it should be secure because my data is very important. So it should be secure and it's reliable. It should not be, we don't want to lose any data. And it's a protect. Yes, that's also another important part of using the DBMS system. But in my personal opinion, but it's true, so when you are using, even though when you select the DBMS system, you need to find the DBMS that provide efficiency based on your application type or data type. Okay, depending on your data type, depending on your business, the problem, it can be the choice. So what you focus on is how we can speed up to access the data. There are different ways to speed up the data, to access the data. Tradition means considering computer history. How can we speed up to access the data? In other words, whenever we encounter such a speed problem, right, considering history of a computer and computer science, how can we solve such a problem? Develop fast media, fast CPU, fast memory, fast hardware, right? That's the solution, but it's limited. Even though we don't mention about the M-DOS rule is the speed of the CPU will be double every 6 months, year and a half, but whatever that is. But it's true, it's the fact. But still, we do not satisfy with that speed. Then how can we? Traditionally and conventionally, whenever we encounter such a speed problem, we use cache. Cache is the solution, still used a lot. Like the cache.
Like money?
Memory. Cache. So, CPU and storage. It's a huge speed gap. There is a memory. even between the memory and CPU, we have L2 cache. Like the USB hard disk drive or any type, it has a cache. For what? To speed. So whenever we encounter a problem, we can solve such the efficiency problem, we can use the cache. What about the database? Database also same thing. So anyone who installed the Oracle database on your computer or at any time, why don't you try? So for your experience. So you can download, you can use or if you log on, sign in the Oracle. I'm not sure what's the name of that the community right now, OTN, the Oracle Technical whatever. So you can download as long as you are not using such a database for the business. So it's okay to use the educational purpose. But if you try to install the Oracle database, it asks a minimum requirement. Minimum requirement is 8 GB of memory or certain size of the memory, huge actually. Then at least it is recommended if you are using for example 32 GB memory, half of them, 50% of the physical memory size is reserved for database. Huge. Okay? Because of that, mostly your project manager or even your department will allocate one very high-end, very fast server and very expensive server as a database. The server. Because it needs something, the requirement. Why we need such the huge requirement of the memory? It will be used for cache. So database use the cache mechanism to speed up to access the data. Okay, that is one thing, and that is called the buffer management. Even though we are not going to discuss the details of how to manage the buffer, but buffer management is a very important part of this DBMS, database management system. Another way how to speed up. So when you have the data, where do you store the data? Mostly not only the database, any computer application, where do you store the data? Where do you store the data? Where can you find the data?
Storage or memory.
Storage? Before memory in your storage? What's the type of the data in your storage? So file, image file, or the video file, Microsoft Word file, or text file. Any types of the data is stored in the file. So file is the data structure to store the whatever. Even the database is, if you, for example, suppose that you are developing the DBMS system. Eventually, by considering the relational model and whatever that is, eventually you need to store the data by table. Where do you store the table? The student table data. Where do you store the instructor table data? It will be the file. So file is the data structure where you can store the data. Then, in other words, in the DBMS, we need to access the file. How to speed up? That's another problem. So when you store the data, it's called the data file. So data file, think about depending on the type of the file, it might be barriers. Okay? Like if your file is ordered, like 1, 2, 3, 4, in case, this is just an example, in case your file is ordered file, then how can you access the data? You can use the benefit of order using binary search, for example. Okay? Using binary, what is a binary search? Cardinal hop and check whether higher, lower, then recursively. So you learn the recursive algorithm in your long time ago, in your freshman, the data structure class, you learned that. So by applying the recursive algorithm, you can find the data eventually. It's much faster than one. Another approach is a sequential search, brute force way, from beginning to the end. So on. So this is the basic way to access the data. but it's not fast enough. So to address that problem, we are going to consider another data structure that can help to speed up to access the data. That is, anyone?
Interpolation.
Interpolation? What does it mean, interpolation?
Algorithm.
This is very similar. The first two characters is the same as the answer. Anyone who have the textbook? If I ask you to find the database or Oracle, how can you find the chapter?
Index.
Using index. You can go to the index, then check the page number, then using the binary search. Sometimes intuitively you can open the textbook. You can use the index. So what is an index? Index is data structure. For what? It's a file data structure, same as the data file, same as your text file, same as any type of file. Index data, index file structure. But this is organized differently. For what? To speed up the search. Okay? So today and the next class, we will talk about first how data file is organized. Data file, data structure, plus index data. So to avoid any confusion, index file structure. Index is also file structure. So we will talk about how data file is organized, how index file. Then finally, using this file structure, index structure, we can store the designed data here. However, you never thought about such how data file is organized, how index is organized. You just use the SQL command. Who is in charge of that? How to organize this, how to organize this. In terms of three schema architecture, conceptual view and external view. This is actually view. Creating view, you can create the view, external view. Conceptual view, you did in the database design. This is what? Internal view. So who design and who use the internal view? You? Actually, you didn't. It's the DBMS vendor. So we are pretending we are designing and developing the DBMS. The reason is that even though we are not going to develop the DBMS engine, but if you understand how your DBMS engine is running, you can understand, you can tune, you can modify the query application, you can manage it, especially if you are interested in the administrator. Definitely you need to understand how the DBMS is organized. So this part we are going to mainly discuss. For this, before we discuss about the indexing, first data file. So how many of you took the operating system class? And how many of them are taking? Okay, some of them. I think that if you are taking, you need to wait a couple of more weeks. But if you already took what is a file in the operating system? It's a data structure to store the data. It's actually nothing but what? It's a byte, one-dimensional byte string. Okay? Physically, actually, it's not physically. It's a low-level data structure. It's nothing but one byte. Whatever the file you are using, image, it's same thing. But you can display differently, very nicely, because it has another data structure, width and the height and the frame, and in case of video, frame number, and so on. In case of Word file, MS Word, Microsoft defined the first 10 bytes used for the file name, and they have their own data structure. Similarly, we are going to use this file for the data. So to do that, our relational data is organized what? Organized by what? Relation is what? Set of data. Set of record. It's better to cut. Cut does not mean really physically cut. We have something structured. So this is the first record, second record, third record, like that. Okay? For one record, we have, when we design the database, relation has a number of the data. Each data has same number of attribute column. So first 10 bytes used for the name, 10 bytes for the SSN, the other 20 bytes is for the address, for example, and the same thing. So for better visualization, we can just show like the two dimensions, one record, another record, and so on. Okay, this is the file. Then if you develop the DBMS using the file, you need to define what is my file data structure, how data file, table file will be organized. So like this way. File consists of number of record. Each record has number of attribute and so on. Okay. Then last time we talked about. So if you are taking the operating system, just before we talk about what? What is this? This is a disk. If you open the hard disk drive, you will see this kind of disk. And disk consists of sector and trap, number of trap in the same position as the cylinder. Then, however, we are not going to directly use the cylinder number, track number, and whatever. Instead, we are using what? This is the block 0, block 1. It's a logical block number or the unit, LBN or LBU. So we use this one, 0, 1, 2, 3, 4. It's the same size as. So when we create the file, file is the data structure. It's not physical, the things. To match, to create the file. File can be divided by same size of the structure. Okay, then match. This one is block 0, this one is block 1, even block 10, like this. Logically, file is one file, data structure, but each file consists of number of what? Block. So this is called the blocking. Any file actually use the blocking, not only database. Your text file use the blocking. Your Microsoft Word use the blocking. Why? This block will be used for what? Same thing that you learn in your operating system. For what? I/O, input and I/O unit. So when you read one record, the read, entire block will be returned. So that is from here and return and keep the where? In the memory. I need only one column, read, 3 bytes. Why we return entire 512 byte block to the memory? It's a waste. Why? Why do we need to return the entire block instead of 3 byte?
We can access block by block but not by byte.
Yes, why we are doing block by block? So if we return 3 bytes only, we can save the transfer rate and we can save the memory space, but we return entire block. Will be difficult. That's also it's complicated. If we divide like the one row, so I need to check all the details instead, just one row. That is one reason. Another. Who knows? Later, if you access this, like think about your text file. If you access this data, there might be higher chance to read Next one. Next one. Really. So when you watch the movie, so you are not going to skip the frame by frame, sequentially read. When you read the select the data, many of time, entire record or entire the column will be written. So for that, even though we need the first time 3 byte, there may be high if we cache. This is bug for management. Cache. Then higher chance. So to speed up also, to speed up input and output, we are going to not only the database, most of the computer system, the operating system use blocking, the block-based input and output. Operating system use 512 byte mostly, not always, but mostly 512 byte. Database. What's the typical size of this block? Multiple of the operating. As I said, database is running on top of operating system. It relies on the operating system, which means if the operating system uses the 512 byte, if I'm using 300, anyway we need to use this one. So it would be better at least equal or multiplication of this. So in real DBMS, including Oracle, the Informix, MySQL, most of them are using 1K or 2K block size. It's bigger than operating system because database need to access, it's more data oriented, the data structure. So 2K, 4K. These are the popular for online transaction processing system. What is the online transaction processing, OLTP? Fast response time, like the banking system. If it takes the 1 minute to withdraw your money, you will leave that banking system. Also, I'm very urgent to buy the Amazon stock. Right now, the Amazon stock is very hot. Why? Amazon is very aggressive nowadays. They purchase the FedEx, the stock, and also the Amazon key. Have you ever heard about Amazon key? So they try to actually access your room, house. So Amazon provide a free access door access, then they can deliver the item inside your room. There might be something security agreement and something like that, but which means they try to keep the entire house. Then another thing is Amazon will extend their business to the pharmacy. Pharmacy is the biggest, one of the biggest market in the United States, but it's not very well organized. For example, if you go to see the doctor the prescribe, nowadays you can specify the pharmacy. Then you need to go to the pharmacy and wait. Sometimes if that is not popular, it takes 2 or 3 days. And especially the senior, they deliver, but it takes time even. But Amazon has, they don't need, they can use delivery, the system. They can use storage. So there's nothing, the new technology they need. Just connect, sell the website to the hospital or the doctor. That's it. Then they can actually, it's a huge business. So, and they are very aggressive. Such as previously they got the Whole Food, it's a retailer market, and so there the stock price is, it's not too late, I believe, if you are interested in the investment. For me, I'm not very interested in any type of the investment personally, but if you are interested, Amazon is still a chance, I believe. And also they are finding second headquarters. The Bridgeport is one of the not they remove. So not good news. But Atlanta is one of the very high chance because it's the south and location wise. But anyway, so why I'm talking about this one, the Amazon one. Why do I mention about the Amazon?
OLTP.
OLTP. So if it takes a time, like I'd like to buy the stock of the Amazon, if it takes 1 minute, 2 minutes, you may lose the chance. Even though within a minute, the stock market will be up and down. So at that time, which one is better? Bigger sized block or smaller sized block? Smaller size is faster. So at that time, 2K, 4K is usual. However, your system is like the big data system. It processes one night the billions of transactions. One night. So which means, which one is more important? Response time or the throughput? Like the turnaround time. Turnaround time is important. So better cache, bigger cache. So bigger size of the block size. Some of them are using 64 megabyte block, which means even though you need only 1 byte of data, 64 megabyte will be memory. Which one? Have you ever heard about the Hadoop? Big data solution? Hadoop used the 64 or 128 megabyte block size because their main goal is to process a huge amount of data, not the fast response time. Okay, so you need to decide that is the factor of the blocking. So block. So we can calculate average number of block used in one block. Average number of record. That is called the blocking factor. Blocking factor means how many average, on average, how many blocks in the one block. Why that is important? To calculate the number of IOs, you need to know number of blocks, right? How can you determine the number of blocks? It depends on number of record. So you can divide number of record data by what? Blocking factor. Block. Okay. So if you have the blocking factor 5, then this will be number of blocks. So you can use that number of blocks as a cost. Later we will use this cost for query optimization also. So this is a blocking factor. So now we can understand that. Going back to the data file structure. So if you remind the data structure, the file structure that you learn in your operating system. File is a data structure to keep the data. File has what? Number of operation. Because it's a data structure. It has a structure for the data, also it has the operation. What kind of operation? File has read, write, modify, and delete. And also, the read is not only just read, we should be able to find, search, okay, find, okay. So find or find the next in case of a sequential search. One more thing is, there are many others, but these are the most popular one for the operation usage method using our data file structure. One is reorganization that I mentioned. Reorg means it's operation in case of chaining data. Because of such a characteristic, sometimes there are two types of. One is chain, variable and fixed record. Fixed record, 10 byte, no matter what. So name is character. 10. Even though my last name is Lee, it will be 10 bytes will be allocated. This is the fixed. Variable length is the only 3 bytes. Later, if I'm changing, add. However, next to this one, another address 1. How can we can allocate another available block? Okay. So because of this one, sometimes your data file is messed up. And whoever did it's a 95 Windows, it's a defragmentation. Have you ever did the defragmentation? Because if your file, the system is slow, Windows system, you can defragment. What is a defragmentation? Because your file is scattered, so you can combine exactly same thing. Reorganization is combining such a scattered data into one. So this is another operation you can find. So after we got this, so this is a file where you can create a table. So when you create a table, one file is created and number of blocks will be allocated. You can insert the data block by in one block. You can do that. Okay, then problem is this file can be. This is the method, but the data structure. There are different ways to store the data. One is like I don't care the order of the data or anything, just add, append the data. Okay? Based on what? As data is inserted, it's called a heap file. Heap file. Where did you hear about the heap data structure? Process. Right? Process, we can?
We have two stuff and header.
Yeah, stack.
Yeah.
Stack is from top to bottom. Can be used for temporary. And heap is dynamically allocate data, add up. Dynamically allocate data. Heap file data structure means just add. Without considering any order. This is a heap. So called the unordered file. We can create the unordered file or heap file. Okay, that's a simple. We can just append. However, when you search the data, keep in mind, in the database file, the searching is very important. How can you find the data? It's only linear search. Sometimes it's called a linear search, or sometimes it's called a brute force search. Sometimes it's called sequential search. No matter what name you are using, it's a sequential search. Okay, linear search. Okay, how can linear search mean from the first, second, you can keep search. Okay, question. When you have, so blocking factor is 5, okay? And the block size is a 512 byte. Then, when you have 100, the rows, 100 record, okay? So, this is the unordered file. This is the given condition. What is the average number of blocks to access the data? What is that? First, how many blocks do we need? Each block has a 5 record. I think that we don't need this information because